Theorem. So let's go ahead and get started. It deals with right triangles. We'll talk about that in just a second. So let's go ahead and plot these points, -1, -2, and -1, 5. Okay, so we're going to go -1 is left or right. So since it's negative, I'm going to go to the left 1. And then for -2, that means go down. So I'll go down 1, 2. So A is going to be down here. Okay, and then B is going to be -1 and then up 5, so it'll be up here somewhere. Okay, so I color coded those in red and blue right there, so there's A and B. Okay, so find the distance between those points. Okay, well the distance is, I can just count, you guys, how many spaces. So from here I'll just go down and count. So there's 1, 2, 3, 4, 5, and then 2 more, 6, 7. So the distance is 7 going down there, okay? All right, and then, so we're going to be dealing with distance here, but that'll be in the next lesson, you guys. We'll talk about distance formula, and Pythagorean Theorem we'll get started with today. So now we're going to plot 3, -2, and connect that point C, that's going to be C, to points A and B. So this means I'm going to go to the right 3, so go over here 1, 2, 3, and then go down 2 because it's negative 1, 2. Okay, remember the first number tells me go left or right, and the second number tells me go up or down. So there's C right there. So we've done that. Now we're going to connect them. Okay, so there it is connected right there. Now do you see that triangle right there? That is called a right triangle. It has created a right triangle, triangle BAC. And typically they always put the right angle, the vertex angle, in the middle right there. So this is a right triangle, and this means triangle right here in geometry, you guys. That triangle symbol means triangle, so this reads triangle BAC, and it's a right triangle because there's a right angle right there. Okay, because this line is perpendicular to this line, so it's a right angle right there, so this makes what's called a right triangle. Okay, and then the two sides, you guys, side AB, this side segment right here, AB is called a leg, and this leg right here, this side AC is also called a leg. This guy is called, it's kind of a funny name, it's called the hypotenuse, you guys, hypotenuse. Okay, so we got two legs of a right triangle and the hypotenuse. Okay, so that's going to lead us into the Pythagorean theorem, you guys. So if we have this right triangle right here with lengths, this is the length A, this is the length B, this is the length C, then the Pythagorean theorem does, it's called A squared plus B squared equals C squared. You might have heard that before. Okay, and this is what the Scarecrow tried to say, but he messed up in The Wizard of Oz. So I read an article that said, did the Scarecrow really get a brain? Well, he kind of goofed up a little bit, but nobody ever notices it because he says it so fast, including me. I didn't notice it until I read that article. All right, so anyways, let's find the missing length. So here's a right triangle right here, okay? So I'm just going to follow this formula right here. 3 would be the A, 4 is the B, and then X is going to be the C. So find the missing length. So 3 squared plus 4 squared equals X squared. So we're going to square 3, which is 9, 3 times 3. Okay, we've got to do the exponents, and then 4 times 4 is 16, so 9 plus 16, and then we add those together. Okay, and then X squared. Well, what number times itself gets me 25? Well, hopefully you guys know that it's going to be 5 right there. 5 times 5, okay? All right, what about this one right here, you guys? Okay, this time the 12 is the A, the X is the B, or you can call the X the A and this the B if you want, but definitely the hypotenuse right here is my C. Let me go back to this formula right here. Okay, notice the hypotenuse is always the one that's by itself. It's always the C squared. You have to recognize that, you guys. Okay, so you can do what the Pythagorean theorem. So I did this side squared plus this side squared equals this side squared, okay? All right, so we got to square these now. 12 squared is 12 times 12, which is 144. 15 squared is 15 times 15, which is 225. Okay, big numbers, I know. And then, okay, now before, what we're going to do now is we're going to get this x squared all by itself. Well, it has a plus 144, so we're going to subtract 144 from both sides. Okay, and then 225 minus 144 is 81, okay? So when we subtract that, we get 81. And what number times itself, what number squared equals 81? Hopefully you guys can recognize that that's going to be 9 right there. Okay, and then before we get into some other ones, I want to go into simplifying radicals. So the rest of this lesson is just learning how to simplify radicals. So the first thing you got to do is get the prime factorization of the number inside. And then after that, you guys, you look for two matching numbers on the inside, and it brings one of them on the outside. So here's an example, you guys. So simplify each radical. Okay, square root of 25. Okay, let's do the first thing first. We're going to get the prime factorization of 25. Okay, well, 25 is just 5 times 5. Okay, so we did the first part. Okay, now let's do this part. Two matching numbers on the inside brings one on the outside. Can you see there's two 5s on the inside? It brings one 5 on the outside, so that's why it equals 5, you guys. The square root of 25 equals 5. Most of you guys probably already knew that, okay? But sometimes you don't get a nice perfect square inside of there. You get something like this, 12. Okay, do you remember how to get to factor trees, you guys, when we're doing prime factorization? Do you remember factor trees? Okay. So 12 is the same as 4 times 3. 3 is prime. So if I could, I would circle that. It's hard for me to circle that at home with my finger right here. I'm doing this with my finger on my little laptop. So I would circle that because it's prime. And then 4 is not prime. 4 breaks down again to 2 times 2. Okay, and then I would circle that, and I would circle that because those guys are prime. Okay, so here's 12. 12 is the same as 2 times 2 times 3. So it's the prime factorization of 12 is 2 times 2 times 3. Okay, and then now we're going to do two matching numbers on the inside, brings one of them on the outside. Can you see these 2's on the inside? Two of them brings one 2 on the outside, and there's not one to match up with that 3, so it stays inside the radical. So two 2's on the inside brings one 2 on the outside, and then the 3 stays left over inside right there. So that's your answer, and we'd say that as 2 root 3. Okay, or some teachers want you to say 2 radical 3, but I like to say 2 root 3. It sounds more sophisticated to me anyways. Okay, let's try another one. Square root of 20. Okay, factor tree. Okay, factor tree, 4 times 5 is 20. Okay, any of those numbers prime? 5 is prime, so if I could, I would circle that. And then 4 breaks down to 2 times 2. So 20 is 2 times 2 times 5. Okay, so I'm going to put those inside the radical. Okay, and then two 2's on the inside brings one of the 2's on the outside. You see how I matched them up with red? These two 2's on the inside brought this one 2 on the outside. This 5 doesn't have anything to match up with, so it stays inside the radical, and that's your answer, 2 root 5. Okay, all right, let's try another one, you guys. Square root of 48. Okay, square root of 48. This one's going to take a little bit of breaking down here. 48 is 6 times 8. There's other ways to get 48, but your final answer is going to be the same prime factorization. So whatever you chose for 48, could have done 12 times 4, could have done 3 times 16, you could have done 2 times 24. There's all kinds of ways to get to 48, but I'm most familiar with 6 times 8. Okay, 6 breaks down to 2 times 3, 8 breaks down to 2 times 4. Okay, this is prime, I would circle that. This is prime, I'd circle that. This is prime, I'd circle that. But this one breaks down again to 2 times 2. Okay, so I'll highlight all those prime numbers in red. Okay, there's 48, all those red numbers. Okay, so I'm going to put all the 2's in order first. So there's 4 2's and a 3. Okay, so there's 48. All right, and then 2 2's on the inside. These two 2's brings this 2 out. These two 2's brings this 2 out, okay, and this 3 stays inside. It's all by itself, left inside right there. Okay, and then go ahead and multiply these, you guys. You're going to get 4 root 3 right there, so that would be your answer, 4 root 3. Okay, you guys, take care.